Go away. Any questions? Yeah. So basically, thank you for the very interesting and a little unusual presentation. And now you could ask anything you want. Speaker is there to answer.
Questions? Anybody?
Just make sure I understand everything. Your entire lecture is basically relating social interactions, humans, to thermodynamics, right? So make sure I understand.
Yeah, I'll give you the short one sentence. The first and second law of thermodynamics govern every system in the universe, including social systems. So that's what we're talking about here. So how that translates is energy is conserved. Entropy, instead of talking about entropy as ensemble, as disorder, the original name for entropy was transformation content. And every day the society is heated, we're about to go with here. Every time the day is heated, you've got a Carnot system heating. So you get when the sun shines, the Earth turns towards the sun shines on it, you get a social expansion. So that's entropy increase. Then when it comes down, this is contact with the hot body of the Carnot engine. When you go back here, you've got decrease in entropy, contraction volume, and it's put in contact with the cold body, the dark night sky. So the change in between that one cycle, between the social system going up to its maximum volume, the example of which is when it's warm in summertime, everybody's out partying, having a good time. When it's 0 degrees, 10 o'clock at night, everybody's in their homes contracted. This is what's called Boerhaave. And the entropy, instead of the change in entropy, is the original name for it is called transformation content, which means that the system is not in its original structure, and the difference in configuration is entropy increase. So that's what we're talking about here. Is that cover that a little bit? There's a quick ball and ring experiment here. So you want to think about this the same way. Think about this as the surface of the Earth.
We have fire extinguisher somewhere around.
If I did this bit out, I'm on Thrace place. But if you heat the ball, in the 17th century they had what's called the fluid theory of heat, or caloric. Before entropy it was called caloric, which was an indivisible particle that couldn't be destroyed. Before that it was terrapinguous. Before that was what's called the matter theory of heat. And they used to think that heat had mass. They couldn't figure out the original experiment. So originally the ball of heat goes through, you heat it for 30 seconds. This is called the ball and ring experiment. And Leiden University, the original thermodynamic university was the École Polytechnique in France. And that's where Sadi Carnot wrote his on motive power fire, that founded from there. Before that, Leiden University did all these heat experiments. This is what's called Boerhaave's law. If you heat a body, it will increase in volume. So we heat for 30 seconds. It doesn't go through the ring. Then we have entropy increase in the metal. Now, just like the surface, the thing going on here, society expands in volume just like this. And you can quantify this. Now, if I cool it, just like the Carnot engine being put in contact with the cool water, we have volume contraction, and the ring goes through. So, and you have entropy change in this process. Now, instead of thinking about entropy as messy room, you want to understand the difference in entropy increase is called transformation content, and it's based on what's called the Euler Reciprocity relationship, which you can look online. And I go back to Leonard Euler's most prolific mathematician, and that's where you want to get your understanding of systems.